logarithm and exponential functions, okay? So let's move into the first part of that. Okay, so first we are talking about the laws for logarithm function, okay? So first we have to know what is for logarithm and what is for exponential functions. Because I believe some of you haven't learned about logarithm and exponential before because you haven't learned about the IG, mathematics, like the further math. Okay, so I have to first tell you what is for logarithm function, okay? So because like here, if we have like a's power of x equals to b, okay, like here, for example, like 2 squared equals to 4, 3 cube equals 27, okay? So now we're just writing down on the like inverse function. So because of here, x can be considered as a logarithm a and b, okay? That is for log a, b. So here you can just consider like a's the power of x equals to the bigger number b, okay? That is the meaning of the logarithm. But just a new notation of this, okay? So for example, like 2 squared equals to 4, you can write down as the 2 equals to logarithm to 4, right? So 2 is the base of the exponential function, okay? So 2 first, we can say 2 squared equals to the bigger number here is 4, okay? 2 squared equals to 4. And what about the third one? Like 3 cubed equals 27. You can set here is for 3 equals to logarithm 327, right? So that is for 3 cube, right? So 3 outer side here is a 3 and so 3 cube equals to the bigger number is 27, okay? That is for here. 3 cube equals 27. So also we are introducing a very new number. It's called E, okay? It's called E. So the E here is always a constant number equals to 2.71 is a constant value. And E can explain a lot of the like the phenomena in our daily life. So we are using E to represent it for the logarithm function, okay? So now we have the E, okay? So we can say, for example, like log E, maybe for log E cube, it equals to 3. That can be considered as E the power of 3 equals to E cube, okay? So also, just to simplify it, we can say that here we can say this logarithm just using a ln means ln e cube equals to 3, okay? So we are just simplify log and a e to ln e cube, okay? So please remember, logarithm is very similar to the trigonometric functions, so it is a function. It's not only a very easy simple, okay? So you can just consider like logarithm 3 and 27 can calculate the final answer 3 here, okay? So just consider like logarithm is a like a function, and we have to put 2 input here, and we will get an output here, okay? That is it. Okay, so let's move into the core laws of this. Okay, so for example, like ln or len AB. So it can be considered as ln A plus ln B. Okay, that is because if you're using like 2.71 power of A times 2.71 power of B, it equals to 2.71 power of A plus B. That is E, right? E power of A plus B equals to E power of A times E plus of B. Okay, so you can just consider like the exponential function is an inverse function with a logarithm function. So here we can say that here, because here's times, right? Here's a times, and finally the answer is added together. Right? So right now we added the ln A ln ln B, we will get a ln AB, okay? Also, if we have a division formula here, like ln A over B, well, it becomes into ln A minus ln B, okay? So the third rule of this is for ln A power of n can be written down as n put forward, and here's n times ln A, okay? That is for these 3 core laws, okay? And also remember, just not to written down in this method. So also students just written down as ln A plus B equal equals to ln A plus ln B. Okay, so that's very not very correct. So please remember all of this, okay? And also, if you write it down as ln A minus B, it also doesn't equals to ln A minus ln B, okay? So they're different. So only we have this one is ln A times B, and here is for ln A over B, okay? That is it. Okay, sure. So let's move into a domain requirement. Okay. So if you're drawing a function of 2 power of x, you were just putting a lot of point here, like when x equals to 1, y equals to 2, right? When x equals to 2, y equals to 4. When x equals to 1, x equals to 0, y equals to 1, right? And you can just calculate a lot of values here, okay? So you can see here, like here is y equals to 2 power of x, right? So we said inverse function also has a property on the graph that they are just symmetrical by the line y equals to x, right? So you can just draw a blue line of this, and you can say the blue line and the red line are the symmetrical graph by y equals to x, right? Okay, so that is like the graph function here. Okay. So also, if we have learned fx, you can find all the values here, you can find is bigger than 0 because the exponential functions has y bigger than 0, right? So here, domain x is bigger than 0. So if you have learned fx, that means always we have to make sure fx is always bigger than 0. That can make sure that len has exactly domain of this, okay? So for example, like the len x plus 1 means the total function x plus 1 here is bigger than 0, which also means the x bigger than -1. And also, for example, like 3 minus x here becomes the function after that because that here is for 3 minus x is bigger than 0 because that is x smaller than 3, okay? But then we can have this. And if you have the two equations at the same place, like ln x plus 1 minus ln 3 minus x, you can set here, like for this equation, we have x bigger than -1, and here is for x smaller than 3. So total domain here is for x bigger than -1 and smaller than 3, okay? That is it. Okay, so that is how we can calculate the domain here, okay? And also here's an example like how to solving logarithm equations. Okay, so maybe here you can find first like logarithm minus logarithm you can find here, right? Logarithm minus logarithm equals to logarithm over or divided a new number here, right? So here we can say like ln x plus 1 or minus ln x can be written as ln x plus 1 over the x, right? So 2 ln 2 you can find here is a constant times like here constant times a ln means power a power of n, right? So here we can set that is for ln 4, right? So the two logarithm function equals to each other, that also means like x plus 1 over x equals to 4. So you can calculate here is for x plus 1 equals to 4x and x equals to 1/3. Okay, that is a final answer here. Okay. Okay, and for the second examples here, you can just also calculate it for like here is for ln 2x squared, right? Minus ln x plus 3, and the final answer is ln 16. You can set that it's 4x squared over x plus 3 because here it's minus. Minus means inside of them is a division, right? It equals to 16. So that will become 4 and x squared equals to 4x plus 12, right? So we can say x minus 2, minus 6 times x plus 2 equals to 0, right? So you can calculate it, and we can set here that x equals to 6 or x equals to -2, okay? X equals 6 and x equals to -2. So you can just add here because also we have to obey the rules for the domain. So like here, 2x is bigger than 0, and x plus 3 is also bigger than 0. So we can set here x bigger than -3 and x bigger than 0. We can only choosing x bigger than 0 as our final answer. Okay? That's for this problem, hoping you can truly understanding for how to calculate, and we can only choosing x equals 6 as our final answer. Okay? That's for this our lessons. Next time. Bye.